These are part 2 to the notes that we took on 10.2 last class. Last class we talked a lot about y equals a times x minus h squared plus k, called vertex form. We talked so much about it that I used Desmos, and I showed you how you could punch these equations into Desmos and you can get your graphs, and you could see what manipulating the h and the k and the a does. By now, what I'm hoping is that you have a small sense of what the a does, what the h does, what the k does. The worksheet that I just passed out to you, worksheet 10.2, the homework for worksheet 10.2, it assumes that you don't need Desmos anymore. So I'm going to say, if you feel like you need extra work, or if you still need to use Desmos, feel free to use Desmos. Josh, you're going to sit next to Josh. If you still need to use Desmos. That's fine. But I eventually want you to be able to get to the worksheet and answer everything from memory, knowing the different parts. And unlike other sections in math, this kind of math, there is no work. You don't have to multiply by anything. You don't have to divide by anything. You don't have to do anything to the equations other than you have to know what the different parts do to the graph. This whole unit or whole section is on parabolas. If I know that there's a parabola and there's an a value, the a value does something different to these graphs. I'm going to show you these different equations. This is y equals 3x squared. This is y equals x squared. This is y equals 1/3 x squared. I show you these 3 examples because that's what you had to do on that very first worksheet. You changed the a value. Sometimes the a was a 3, sometimes it was a 1, sometimes it was a 1/3. What happens when you have a value that is greater than 1, either positive or negative? It makes it narrower. What happens when the a is 1? It's a normal parabola. What happens when the a value is less than 1? It doesn't matter if it's positive or negative. It makes it wider. And you know that because you've been playing around with that on Desmos with that little slider. Couple of little hints. Sometimes you can just figure out what the first unit is going to be. First unit to the right is 3 up. That has a lot to do with that a value. First unit to the left, 3 up. That has a lot to do with that a value. It doesn't do that the whole way down the line, but it might give you an idea of a way to remember what it does. If it's a 1, to the right 1, up 1. To the right 1, up 1/3. To the right 1, up 1/3. To the left 1, up 1/3. That's how I sort of remember it. Other things about the a value. If it's a positive a value, this is a positive 3, it makes a smiley face. It's a happy parabola. If it's a negative parabola or negative a, it would be going downward. If it was negative 3x squared, then the whole graph would be flipped. Y equals negative 3x squared. It would be the skinny graph going downward. Simple, right? Like you just have to know what the a does, and then you know what the graph is going to look like. The a value is important. The h and the k is important. What is the h and the k? The h and the k is your actual vertex. It's the lowest point. It's the highest point depending which way your graph is facing. The only thing you have to remember about h and k, the vertex, this is your x coordinate, this is your y coordinate. The h is the opposite, k is the same in your equations. So when you're dealing with an equation, if you have an equation that's like this, y equals negative 2x plus 3 squared minus 4, you know that it's negative 2, meaning opening down. You know that it's narrow. You know that the h would be the opposite of this, -3. The k is the same as this, -4. Your vertex would be at -3, -4. You can go and graph that. You can go to -3, -4, opening down and have a nice narrow graph. So that's what we got to know. We got to know h and k are the opposite of h, the thing that affects the x, and the same as the k, which is outside of the parentheses. There's this other thing, this other questions that they're going to ask you that's called for, what's the axis of symmetry? That's the line that cuts this parabola right down the middle. Since it's a vertical line, it's always x equals. And because we have a variable there, we're going to say it's the x coordinate of the vertex, otherwise known as x is equal to h. If you know that, you know the axis of symmetry. The axis of symmetry here is x equals 0. Domain and range are the same. A graph is increasing when its y values are increasing. This is increasing here. I would describe it as it's increasing when x is greater than 0. It's decreasing because it's getting smaller here. I would say it's decreasing when x is less than 0. So that's what this is describing. It says even though you're looking at the y values, you describe it by using the x values, and the same thing with decreasing and increasing. Two more things, and then we'll get to some examples. A solution. If something is asking, is this a solution? It's saying, is it on the function? Does that x produce that y? If you're not sure, a lot of times you can plug something in. Like if you're looking at this and you say, I wonder if -1 is a solution. You don't know if it's a solution. Is that on the graph? You can plug this in. -1 times -1. Does it equal that y value? If it does, it is a solution. If it doesn't, it's not a solution. Is 0, 1 a solution? You plug in the x, plug 0 into it. 0 squared. Does that equal 1? No, it's not a solution. The last thing that I have up here is talking about transformations. To write a transformation, we're going to use this notation where we say the xy's, all the xy's are going to be transformed by by shifting the x 2 more to the right and 3 up. And that's going to represent right 2 and up 3. If you need to go to the left, you would subtract 2 from x, or you would subtract however many you're trying to go. If you're trying to go down, you subtract. If you're trying to go up, you add to the y, and so on. This is how you write it. And that'll be important as you get to later questions. So, we've done a lot of examples. We did several of these things last time. You may or may not be done with worksheet 2 notes. And so what I did in my last class was I picked a couple from here, and then hopefully you'll be able to answer everything else. This is in section C. That was the hardest thing to say right there. Ooh, woo. Sorry. Something else might have slipped out right there. I'm sorry if I did. Number 1 of this section is going to ask you some questions that we haven't done on the video notes yet. So let's do some of these things. It says, what's h, what's k, what's the vertex, is there a min or max, is there an axis of symmetry, the domain and the range. Here's how I do it. Sometimes I will write this for my beginners, but most of you will get this down pretty easy. I write the vertex form right above the equation. Let me zoom in on that. I wrote y equals a x minus h squared plus k right above it, because then I know what the different parts are going to be. A is the thing in front. How many of these groups do we have? We have an invisible one. H. It's kind of hard. Remember, this is a negative H, opposite of H. What's our H going to be? You just remember that it's the opposite of this negative 4. It's 4. K is the same, opposite, same. 1. So what does that mean your vertex is? Your vertex is H comma K, or 4 comma 1. That's what our notes say. Since the A is a positive 1, that means it's going to open upwards. Because it's opening upwards, is there a minimum or a maximum? There is a minimum. If that one confuses you, then what I would recommend is that maybe you should go to the graph first. And if it says you're graphing at 4, 1, you go to the right 4 and up 1. You put your vertex there. I know my vertex is at 4, 1 because it has a horizontal shift of 4 units to the right and I'm up 1. And the A value is a 1 to the right 1, up 1, to the left 1, up 1. It makes this normal shaped parabola like this in red. Can't you tell now that there has to be a minimum? What would the axis of symmetry be? The AOS, which stands for axis of symmetry. What is the line that cuts it right down the middle? In our notes, we said that X was equal to H. Well, what's the H? The H is 4. 4, X equals 4 is the line that would cut it right down the middle. It's a vertical line, so it's always X equals. Because our domain, because we use any X value we want, we can use all real X values, all real numbers. I can plug in -1 all the way through 100 to 1,000,000 to -1 billion. But the range, we only use certain Y values. In my class, I held a ruler and I said we only had Y values that were here and above. Because we have Y values in our graph that are here and above, we're using Y values that are greater than or equal to that minimum value. It's almost like we could have said it's Y is greater than or equal to the K value, which it is. So now you have this. You're going to do the same thing on 2 and 3. You'll answer some questions on part C as well. But I want to do at least one example of part D because it deals with that translation. So I'm going to switch over to this. It'll be my last example and we'll end your notes after this one. It says, if the graph of f of x is equal to x squared, I'm just going to put this in red and I'm going to draw a little mini graph over here and graph x squared. Here's x squared. H is 0, k is 0. Think about it. X minus 0 squared plus 0. Like you're adding nothing outside the squared term. You're adding or subtracting nothing inside the squared term. It's the same thing as 0, 0. The vertex is 0, 0 in vertex form. So now that you have your first equation in red, let's go to the next equation. I'll do this one in blue. Here's g of x. G of x is x plus 3 squared minus 2. They've shifted it. If you know what the vertex is supposed to be, then think about what that graph would look like. H would not be positive 3. H would be opposite, negative 3. See how much there's like no work. It's just knowing the opposite. K is going to be the same. If I know that the vertex is at negative 3, negative 2, I go to the left, 1, 2, 3, and down 2. My g of x still has a positive 1. It's the same size parabola. It's just shifted. This is the g of x one. Here's my f of x that's in red. My g of x is in blue. Then they say f of x is mapped onto g of x. They're going to move the red graph onto the blue graph by transforming of which choice? Would I move this to the right 2? Right 3 and up 2? Would I move it to right 3 and down 2? Would I move it left 3 and up 2? Would I move it left 3 and down 2? A, B, C, or D? Tell the person you're sitting next to what you think it is. If you said D, you are correct. D is the right answer. You moved it to the left 3 and down 1. It's almost like you once you know what the H and the K is, you know the horizontal and vertical shift. That's it. No work. Just knowing what each letter does. That's the main idea of section 2. If you need Desmos, use it, but if not, try to do everything without Desmos, just maybe looking at your equations. We're going to stop your notes right there.